AFCI breakers are designed to trip when they detect a certain level of arcing faults. Some smoke detectors may have incompatible circuitry or internal components that can cause false AFCI trips. When smoke detectors are nearing the end of their battery life, they emit a low-frequency chirp. This chirp can generate a small surge in current, which could trigger the AFCI breaker if it is highly sensitive. Loose connections or improper wiring in the circuit can also cause arcing faults and trip the AFCI breaker. Here are some troubleshooting steps. Firstly, check smoke detector compatibility. Consult the manufacturer specifications for the AFCI breaker and the smoke detector to ensure they are compatible. Secondly, replace smoke detector batteries. If the smoke detectors are chirping due to low batteries, replace them with fresh batteries. Thirdly, test the circuit. Use a multimeter or other testing equipment to verify that the wiring is correct and there are no arcing faults. Fourthly, try different smoke detectors. Install smoke detectors from different manufacturers or models to see if the issue persists. Fifthly, adjust AFCI trip level. Some AFCI breakers have adjustable trip levels. If possible, try setting the trip level to a less sensitive setting. While there are no specific limitations on downstream devices for AFCI breakers in the electrical code, it is generally recommended to avoid connecting large inductive loads or devices that generate significant harmonics to AFCI circuits. Smoke detectors typically fall into a low load category and should not directly cause AFCI trips. Here are some additional considerations. Older AFCI breakers may be more sensitive than newer models. Interconnected smoke detectors may cause a larger surge in current when they chirp, potentially tripping the AFCI breaker. Installing surge protection devices on the circuit may help reduce false AFCI trips caused by surges from external sources. To elaborate on incompatible devices, consider that AFCI breakers operate by monitoring the current flow in the circuit. They are designed to detect the unique signatures of arc faults, which are characterized by erratic and high-frequency current fluctuations. Certain electronic components within smoke detectors, particularly older models or those with less sophisticated designs, might generate electrical noise or current patterns that mimic the characteristics of an arc fault. This can lead to the AFCI breaker misinterpreting the normal operation of the smoke detector as a dangerous arcing condition, causing it to trip. Furthermore, some smoke detectors employ capacitive power supplies or other nonlinear circuits that can introduce harmonics into the current waveform. These harmonics, which are multiples of the fundamental frequency of the alternating current, can also confuse the AFCI breaker and trigger a false trip. The sensitivity of the AFCI breaker plays a significant role in determining whether a particular smoke detector will cause problems. Breakers with tighter tolerances and more advanced detection algorithms are less likely to be affected by spurious signals from downstream devices. However, older or less sophisticated AFCI breakers may be more prone to nuisance tripping. Regarding the low battery chirp, when a smoke detector's battery nears the end of its life, the device initiates a low battery warning, typically in the form of a periodic chirp. This chirp is produced by a small electronic circuit within the smoke detector that momentarily activates a sound-producing element, such as a piezoelectric buzzer. The activation of this circuit requires a brief surge of current from the battery. While the current surge associated with a single chirp is usually small, it can become problematic when combined with other factors. For instance, if the wiring in the circuit is slightly compromised, or if the AFCI breaker is particularly sensitive, the added current surge from the chirp could be enough to push the circuit's electrical characteristics beyond the breaker's tripping threshold. Moreover, in interconnected smoke detector systems, where multiple detectors are wired together to provide coordinated alerts, the simultaneous chirping of several detectors could create a more substantial current surge, increasing the likelihood of an AFCI trip. In terms of faulty wiring, loose connections, damaged insulation, and improper grounding can all contribute to arcing faults. These faults occur when electrical current jumps across an unintended gap, creating a spark and generating heat. AFCI breakers are specifically designed to detect these arcing conditions, which are a major cause of electrical fires. Even seemingly minor wiring issues can create significant arcing faults. For example, a loose wire nut in a junction box can allow the conductors to move and intermittently lose contact, resulting in a brief but intense arc. Similarly, a nail or screw that pierces the insulation of a wire can create a path for current to leak to ground, leading to an arcing fault. The location of the wiring fault also matters. Faults that occur closer to the AFCI breaker are more likely to cause a trip than faults that are farther away, as the breaker has a more direct view of the fault current. When checking smoke detector compatibility, you should refer to the manufacturer's documentation for both the AFCI breaker and the smoke detector. This documentation should provide information on compatibility testing and any known issues. Some manufacturers may even publish lists of compatible devices. Look for statements that explicitly confirm compatibility between the AFCI breaker and the specific model of smoke detector you are using. Pay attention to any warnings or disclaimers regarding the use of certain types of smoke detectors with AFCI breakers. If the documentation is unclear or unavailable, contact the manufacturers directly for clarification. They may be able to provide additional information or recommendations. When replacing smoke detector batteries, use only the type of batteries recommended by the smoke detector manufacturer. Different types of batteries have different voltage and current characteristics, and using the wrong type can affect the performance of the smoke detector and potentially increase the risk of false AFCI trips. Ensure that the batteries are fresh and properly installed, paying attention to the polarity markings. After replacing the batteries, test the smoke detector to ensure that it is functioning correctly. Press the test button on the smoke detector and listen for a loud, clear alarm sound. If the alarm is weak or non-existent, double-check the battery installation and replace the batteries again if necessary. When testing the circuit with a multimeter or other testing equipment, use caution and follow all safety precautions. Ensure that the power to the circuit is turned off before making any measurements. Use a properly rated multimeter and wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Check for voltage between the hot and neutral conductors, the hot and ground conductors, and the neutral and ground conductors. The voltage readings should be consistent with the expected values for the circuit. Look for any signs of loose connections, damaged insulation, or improper grounding. If you find any problems, correct them immediately. An insulation resistance tester, also known as a megometer or megger, is a specialized instrument used to measure the resistance of insulation. It applies a high DC voltage to the insulation and measures the resulting current flow. The insulation resistance is calculated by dividing the applied voltage by the measured current. A high insulation resistance indicates that the insulation is in good condition, while a low insulation resistance indicates that the insulation is compromised. When using an insulation resistance tester, follow the manufacturer's instructions carefully. Ensure that the circuit is de-energized and that all connected equipment is disconnected. Apply the test leads to the conductors you want to test and apply the test voltage. Read the insulation resistance value from the meter. Compare the measured value to the minimum acceptable value specified by the manufacturer or relevant standards. When trying different smoke detectors, choose smoke detectors from reputable manufacturers with a history of producing high-quality product. Look for smoke detectors that are specifically designed to be compatible with AFCI breakers. Consider smoke detectors with advanced features such as photoelectric sensors or dual sensor technology, which may be less prone to causing false AFCI trips. Install the new smoke detectors in the same locations as the old ones and test them thoroughly. Monitor the circuit for any signs of AFCI tripping. If the problem persists, try a different brand or model of smoke detector. Some AFCI breakers have adjustable trip levels which allow you to fine-tune the breaker's sensitivity to arc faults. However, adjusting the trip level should only be done by a qualified electrician, as setting it too low can compromise the breaker's ability to protect against dangerous arcing conditions. Before adjusting the trip level, consult the manufacturer's documentation for the AFCI breaker. This documentation should provide instructions on how to adjust the trip level and any precautions that should be taken. Make small adjustments to the trip level and monitor the circuit for any changes in AFCI tripping behavior. If the problem persists, return the trip level to its original setting. Regarding avoiding connecting large inductive loads or devices that generate significant harmonics, inductive loads, such as motors and transformers, can create voltage surges and current distortions that can interfere with the operation of AFCI breakers. Devices that generate significant harmonics, such as electronic ballasts and variable frequency drives, can also cause problems. When designing circuits with AFCI breakers, try to separate these types of loads onto separate circuits. Use filters or other mitigation techniques to reduce the impact of inductive loads and harmonics on the AFCI breaker. Older AFCI breakers may use less sophisticated detection algorithms and have tighter tolerances, making them more susceptible to nuisance tripping. If you are experiencing problems with AFCI tripping, consider replacing your older AFCI breakers with newer models. Newer AFCI breakers typically have improved detection algorithms and wider tolerances, making them less prone to false tripping. Interconnected smoke detectors are wired together so that when one detector senses smoke, all of the detectors in the system sound an alarm. This can be a valuable safety feature, as it ensures that everyone in the building is alerted to a fire, even if they are not near the detector that initially sensed the smoke. However, interconnected smoke detectors can also increase the risk of AFCI tripping. When one detector sounds an alarm, it sends a signal to all of the other detectors in the system. This signal can create a surge in current that can trip the AFCI breaker. To reduce the risk of AFCI tripping with interconnected smoke detectors, use smoke detectors that are specifically designed to be compatible with interconnected systems. Consider using wireless interconnected smoke detectors, which do not require wiring between the detectors. Surge protection devices can help to protect against voltage surges caused by lightning strikes, power grid fluctuations, and other sources. These surges can damage electronic equipment and can also cause AFCI breakers to trip. Installing surge protection devices on the circuit can help to reduce the risk of false AFCI trips caused by surges. Choose surge protection devices that are specifically designed to protect against the types of surges that are common in your area. Install the surge protection devices according to the manufacturer's instructions. Remember to consult the manufacturer's documentation for the AFCI breaker and the smoke detectors to ensure compatibility and proper installation. If the problem persists, consult a qualified electrician to diagnose and resolve the issue. AFCI breakers are designed to protect against arc faults, which are a major cause of electrical fires. While they can sometimes be prone to nuisance tripping, it is important to ensure that they are functioning properly to protect your home and family. If you are experiencing frequent AFCI tripping, do not simply disable the breaker. Instead, take the time to troubleshoot the problem and identify the underlying cause. Once you have identified the cause, you can take steps to correct it and prevent future tripping. This could involve replacing incompatible devices, repairing faulty wiring, or adjusting the AFCI trip level. By taking these steps, you can ensure that your AFCI breakers are providing the protection they are designed to provide. Understanding the principles of AFCI operation and the potential causes of nuisance tripping is essential for resolving these issues effectively. AFCI breakers work by monitoring the current waveform in a circuit for unusual patterns that indicate the presence of an arc fault. An arc fault is an unintentional electrical discharge between two or more conductors, or between a conductor and ground. These faults can generate intense heat and can ignite nearby combustible materials, leading to a fire. AFCI breakers are designed to detect these faults early and trip the circuit to prevent a fire from starting. There are two main types of AFCI breakers: branch/feeder AFCI breakers and combination AFCI breakers. Branch/feeder AFCI breakers protect against parallel arc faults, which occur between two conductors. Combination AFCI breakers protect against both parallel and series arc faults. Series arc faults occur within a single conductor, such as a broken wire. The sensitivity of an AFCI breaker is determined by its tripping threshold, which is the amount of arc fault current required to trip the breaker. Tripping threshold is typically set at a relatively low level in order to detect arc faults early. However, this can also make AFCI breakers prone to nuisance tripping. There are several factors that can contribute to nuisance tripping, including incompatible devices, low battery chirps from smoke detectors, and faulty wiring. To troubleshoot AFCI tripping problems, it is important to systematically investigate the potential causes and eliminate them one by one. Start by checking the compatibility of the devices connected to the circuit. Ensure that all devices are listed and labeled for use with AFCI breakers. Replace any devices that are not compatible. Next, check the smoke detectors for low batteries. Replace the batteries if necessary. If the problem persists, inspect the wiring in the circuit for any signs of damage or loose connections. Repair any faulty wiring. If you have tried all of these steps and the problem still persists, you may need to adjust the AFCI trip level. However, this should only be done by a qualified electrician. Adjusting a trip level too low can compromise the breaker's ability to protect against arc faults. Finally, consider the age of the AFCI breaker. Older AFCI breakers may be more sensitive than newer models. If you have an older AFCI breaker, consider replacing it with a newer model. Remember that AFCI breakers are an important safety device that can help to prevent electrical fires. If you are experiencing frequent AFCI tripping, do not simply disable the breaker. Instead, take the time to troubleshoot the problem and identify the underlying cause. Once you have identified the cause, you can take steps to correct it and prevent future tripping. Also, when troubleshooting, consider the potential for ground faults. While AFCI breakers are primarily designed to detect arc faults, they can also be sensitive to ground faults, especially if the ground fault current is high frequency. A ground fault occurs when current flows from a hot conductor to ground, typically through an unintended path. This can happen if the insulation on a wire is damaged, or if a device is not properly grounded. Ground faults can be dangerous because they can cause electric shock. They can also lead to fires if the ground fault current is high enough to ignite nearby combustible materials. If you suspect that the ground fault may be causing AFCI tripping, use a ground fault indicator to test the circuit. A ground fault indicator is a device that detects the presence of ground fault current. If the indicator detects ground fault current, you will need to locate and repair the ground fault. Consider the location of the circuit and its susceptibility to external factors. For example, circuits in areas with high humidity or moisture levels may be more prone to ground faults and AFCI tripping. Similarly, circuits that are exposed to vibration or mechanical stress may be more likely to develop loose connections or damaged wiring, which can also lead to AFCI tripping. In these cases, you may need to take additional precautions to protect the circuit, such as using moisture-resistant wiring or providing additional support for the wiring. Furthermore, evaluate the overall electrical load in the circuit. Overloaded circuits can cause excessive heat, which can damage wiring and insulation, increasing the risk of arc faults and ground faults. If the circuit is overloaded, reduce the load by moving some of the devices to a different circuit. Finally, keep detailed records of all troubleshooting steps and findings. This will help you to track your progress and identify any patterns or trends. It will also be helpful if you need to consult with an electrician or other qualified professional. By following these steps, you can effectively troubleshoot AFCI tripping problems and ensure that your electrical system is safe and reliable.